Hello again, YouTube. The last time I was using libopencm, it was an extremely long video, longer than it should have been, but that's what you get when you try coding. We basically used libopencm3 to flash this LED using a timer 2 interrupt. Just using an interrupt. This is the 1BTC, which is an STM32F415 device. So in the course of that video, I had a bit of a questioning rant about the use of the functions and specifically bitwise operations and or an exclusive or to set the bits of special function registers required to configure this timer to do what you want. We were using timer 2, and I'm coming back to that because I just was curious about what, if any, the benefit was of Bitwise compared to Bitfields, which I would be more used to using Bitfields coming from the microchip sort of thing. So that example I did the last time was actually accepted by 1BitSquared and went into 1BTC examples. Now that was forked. I forked my own copy of this because I did a fork and I did a branch just to compare Bitfields with bitwise operations. So if I clone this, and submodule, yep, and update. So that's pulling in libopencm3, which the examples use. And if I make all those projects now, they should make, there is one problem with, it's a warning on some, it's a different project to the timer, so we'll ignore that. So if I go into examples 1BTC and timer 2 is the example I did, and Emacs, so now the only difference in what's in this example, what was accepted is the fact that I took my block of code and stuck it into a function. So in the same way as there is a clock setup and a GPIO setup function, I took my block of code and did that. So I created, that's the example, but I've actually created another branch. So if I get branch, right, I'm going to have to reload this. Now in this, my change is I've added this switch which you can either turn on or off, called Bitfield. Now if you've Bitfield enabled, it pulls in a header file, timer 2 Bitfields. So the best way to look at this is if I go to the manual. Now the manual is, there's loads of different ways of configuring timers. So there's loads of documentation here on the various counting up, counting down, probably PWM, but you get to the registers. Now the special function registers, sorry, I've lost my way on the keyboard. Did it again. Right, there's the registers for timer 2, and you can see that it's each register is made up of bits that mean something. So that first bit is the counter enable, CEN, and then you've got a single bit which is UDIS, URS, OPM, DIR and CMS. So this header file that I'm including defines this register as a structure. The CR1 register is a structure. It's a Bitfield and it's 32 bits wide. The first bit is the enable, second bit this, and on, and the CMS is going to be 1, 2, 3, 4 bits 5 and 6. So bits 5 and 6 there, that's a Bitfield made up of 2 bits for the CMS, and that's the center alignment mode. So there's a couple of there's 4 different settings for that value. So each one of these registers is a Bitfield, the special function registers, and you go through these. Most of them are structures, but there are a couple of unions. This one here, CCMR1, and there's CCMR2 and another few, but that is a union because it has 2 different meanings. The register has 2 different meanings depending on whether it's an input or an output. So there's, I've actually gone past 1 to 2, but I'll go back up to 1. There's 1. So the first 2 bits are always CC1S, but bits 2 and 3, if it's an output you're working with, then it's OC1FE and OC1PE. Whereas if it's an input, there are 2 bits in the field, and the field is IC1PSC. So that's why there's 2 structured here. There's an input, and that's the bit fields for an input when you're talking about an input in this register, and that's the bits when you're talking about outputs. So there's a union between the 2. There's only one. There's a 32-bit value. This union is a 32-bit value, but you can manipulate it 2 different ways because it is 2 different. It can map to 2 different structures. That's why it's a union. So that's all these registers are defined, and then at the end I've got this superstructure which contains all these different registers, and that is right down at the bottom of the chapter, and it gives them the memory map for the special function registers. So you can see that this memory map, it starts at 0. The offset is 0, and that's CR1. Then at 4, an offset of 4, you've got CR2, SMCR, DIER, etc., etc., the whole way down. And that's what this superstructure is doing. It's doing the CR1, CR2, SMCR, DIER, defining the actual special function registers, and each one of those, because they're a structure or a union, specifies the bit fields that are going to be used. So back to the actual C code. And the C code, the only thing I've done is added another timer 2 setup function. Now it's executing exactly the same functionality as the original timer 2 setup function, which is in 1Bitsy examples, which uses the libopencm function calls to do bitwise ands and ors to set the bits to the value you want, given the timer configuration that you want. So in the bit field operation, so if you take for example EGR, that's setting the EGR timer 2, the EGR register, and setting the UG bit to 1. Now that doesn't mean a great deal when you're talking about if you wanted to start. In this case, we're trying to start a 1-second timer, and it doesn't mean much in those terms of a 1-second timer that repeats, which is what we're trying to do. 1-second timer that repeats. EGR UG bit doesn't actually mean anything, but if you go back up the data sheet these timer blocks are too big. I thought I'd gone script past it there for a minute. There I am. So we went through this documentation in the last video, and you get a paragraph. We were doing counting up counting mode, and you get a paragraph like that, which says you want to set, well, in what I'm trying to do, I'm trying to use the update event to change the toggle the LED, and if I'm trying to do that update event, then I have to set the UG bit in the EGR register, and that's kind of a one-to-one mapping with this line of code. And in the other case, I've got a comment on the end of this line. That's what this line of code does, the calling the function timer generate event. That's the function call I needed to actually do that, but the comment at the end of that line says I'm actually trying to set the UG bit of the EGR register, sort of thing. It's I suppose doctors differ and patients die when it comes to anything in programming, but yeah, I prefer that's got the Bitfield thing, and that doesn't mean to say you couldn't do a more representative implementation using bitwise operations that reflected the data sheet. That's not the reason why I did this anyway. The reason why I did this was to compare the two. So we previously we looked at flashing the LED with libopencm3 using bitwise operations. I'm now going to try and do the same thing using the Bitfields ARM non-GDB. Just check that it's there. Yep. So, load code, and if I go into put this always on top for the minute, and run that from the start, if the debugger's flashing. So there is our LED flashing again, and as I said the last time, I'm not sure about the 1 second, but it's more or less, I'd say, and it's not like I really want to check it on the scope or anything. So we've done nothing here but change the implementation of flashing a LED with timer 1. The only reason I really did this was to compare the implementations. So that was using a Bitfield. So if I disassemble that, object dump, if I disassemble that, and that was Bitfield, and if I now go and comment out that, so we're using the bitwise operation, now if I get rid of all the other, this is just the disassembly for that C file, so we only want timer 2 setup. It's the only function I'm really interested in. I want to compare that with the bitwise version. So if we could take the same function So now, on the face of it, the one on the right, the Bitfield, which we've just created, is longer. But the difference is, one of the differences is that this instruction is a branch, and it's branching to this timer set mode function. So during execution, we'll branch to this function, do some code, do a number of lines of code there, and jump back to this next address, 22. Now these aren't actually addresses, this is just from the assembler. So if I go and actually disassemble the whole the whole elf from the whole program, and go call that prog.asm. So this was the Bitwise version. So if I go over here and load the whole program, so that first function I'm trying to jump to, now the first two was just set the peripheral clock enable and reset the timer, and they're more or less the same in both versions, so I won't worry about them. But timer set mode, if I timer set mode is 8 instructions. So over here I branched to timer set mode, but I've got to add 8 instructions. Similarly with this prescaler, oops. Timer set prescaler is 2. So that's simple. Set period is just under it, it's 2 as well. Enable update event. Enable update event is up there, and that's 4. Timer update on any, that's up above as well, and that's 4. Generate event, that's down below, and that's 4 as well. Enable IRQ. That's the interrupt controller. Enable IRQ, that's not the one we're looking for. Timer enable IRQ, that's 4. Continuous mode. Sorry, fingers. Another 4. Preload is another 4. And that's that interrupt. Enable the interrupt in the interrupt controller. We can leave that because that's in both examples. And enable counter, that's just at the bottom of this, and that's another 4. So now, getting back to if I get rid of the first line, the Bitwise version, including all the function calls and all the returns, line 77. So that's 77 instructions. The Bitfield version is 61. So there's actually not a great deal of difference as it's implemented. And probably the overhead, or some of the overhead, is a number of function calls. So you're jumping, you're doing a lot of branches and returns. So if you inlined or unrolled all those function calls, they would probably be very similar. And there is an argument that would say, well, this is just initialization code which is run once when you start up, so it doesn't matter. I mean, it's going to just be a slightly different in length, but it's not a loop that's at the core of your functionality. But I've heard people, I've seen responses on Stack Exchange that said that Bitfields should be phased out of the C programming language because their Bitwise operations are much more efficient. And perhaps there's an element of truth there, but there's also questions about readability, and I'm sure people would argue that that line of code setting the UG bit in the EGR register to 1 isn't as readable to the eye as timer generate event, but that kind of depends on your knowledge of the timer module, that peripheral module that you're trying to configure. 6 of one, half a dozen of the other. I suppose it's I'm kind of surprised. I thought, given all the, I suppose it's like anything in programming, people have their ways of doing things. So 6 of one, half a dozen of the other. I am kind of surprised that the Bitfields are more or less the same, given that implementation with a lot of function calls. I'll leave it there. Thanks a million for watching.